Hello everyone, my name is Yazid Ahmed Shuaib from OKAN20f studying master's program in architecture. The main topic of my presentation will be sustainable architecture in terms of ecological settlements and examples from around the world with a case study of Batikent urban settlement which is in Ankara. I finished my undergraduate studies in OKAN20f, which immediately after that I started working in an interior design company as one of the architectural designers in the office. After that, I started also working in a metalworks company, which I'm also one of the designers in the company. Right now, I'm also studying my master's program in OKAN20f, and I'm in my second semester in studying my master's within the university. Now to my topic. But first, I'm going to start with what's sustainability. Sustainability is defined by Brundtland Common Future Reports in the UN as the ability to afford today's needs without making concessions from opportunity to affording future generations' needs. This means sustainable development goes hand in hand with sustainable urbanization. Urbanization, if planned and ordered, is the key of achieving a very ecologically sustainable and efficient design. As seen on the graph, the annual consumption of energy in cities is growing exponentially and is growing heavily globally on our environments and ecological systems. So meaning we need to manage this and maintain these systems where we can be able to afford the standard of living for our future generations. Another thing I would like to talk about is ecological planning. Firstly, what's ecological planning? It can be defined as the use of socio-cultural and biophysical information to provide options for policy and decision makers regarding the interpretation between humans and their environment. Because, as we all know, the more impact humans have on their natural environments, the more we increase the scale and magnitude of natural phenomena happening in the same ecological systems, either directly or indirectly. Urban ecology is a scientific study of relationships of living organisms with each other and their surroundings in context of urban environments. One of the main principles in ecological application foundation is the deep environmental approach. This can also be further divided into two. That's the shallow ecological movement and the deep ecological movement. Below is trying to ensure how we can all manage our sustainable environments, either individually through our industrial, that's manufacturing works, and as the whole environment altogether. Principles of urban settlement. The principles of urban settlements can be divided into 5 main parts, which are the physical, the environmental, the infrastructure, the social, and the technological. The physical environment deals more with the location, the geography, and the climate conditions of the site, along with the topography, the topology, the solar conditions, but the basic things we require during our main site analysis. While the environmental analysis deals with an in-depth look of the settlement and its surrounding and how it corresponds with the surrounding, its energy consumption, the material usage, the planning and infrastructure of the project. Then infrastructure deals with the public services, the transportation networks, the range from the buildings, and the other utilities and services that can be provided for this site. Then the social deals with the cohesion of the amenities, the identity and the quality of well-being, and all other social well-beings. And the technology talks about the machines and appliances that the users will use within the site. This will range from small common household devices to vehicles and other major appliances used in this settlement. In this next slide, I'm showing criteria of comparisons carried out for analysis of several different types of urban settlements from around the world. Under this criteria, I looked at the accessibility, the energy consumption, and also the design and planning of this settlement. So the settlements that I looked at were Batikent in Turkey, Mikeli, Masdar, Solar City, Freiburg, Vancouver, Vanubar, THA City in Karachi, Pakistan, Lebanon in Germany, Kukuban in Australia, and then finally Konohana in Japan. So I compared different, like I said, criteria and determined which the criteria I can use for my design and which ones I feel we can work on in the future. So I also discussed the SWOT analysis of each and every one of them in this criteria. So in conclusion, what I'm trying to say about visions for EcoCity is, yes, it's good to have planning of these modern settlements, which contain appealing and very important concepts such as the harmony of environment and the maximization of people's quality of life, while still maintaining the balance in the ecological system. But it's also important to know that we can't just discuss it, we have to practice it. So for us to achieve the optimum comfort of living, we have to make sure we practice all these ecological criteria that we've seen so far. So without further ado, let me move into my case study. My case study for this semester was Batikent. Batikent, the literal translation means West Town in English. Batikent is an urban settlement that was first conceived in 1974 in Ankara. Dalokay, who was also an architect and also the mayor of Ankara at that moment. This site is almost 11,000 hectares in size. It is 11 kilometers from the city center of Ankara and is located along the Ankara-Istanbul highway. It is surrounded by the Ataturk Forest Farm in the west, the Ostim industrial area in the northeast, and a strip of small industrial sites in the south. Going into the design and concepts of Batikent, I would like to discuss its origins first. It was first thought of after the Second World War. The larger cities in Turkey were drastically being overpopulated by the moving population from the rural areas. Thanks to the influence of technological boom and mechanization in agriculture and the major global industrialization, which sparked a massive migration from rural to urban areas, not just in Turkey but all across the world. It means to tackle this issue, the Ankara municipal government collaborated with other organizations like the Kent Group, which consisted of the central government, municipal, and the Association of Housing Corporation. This project was later named Batikent. Batikent was developed to serve as a crown jewel for solutions of housing problem and established itself as an example model in which implementations for future urban projects can be used. So meaning this project stood out from all others and served as a futuristic design at the moment it was conceived. So like I said, the first stages of the project started in 1974 and then the design was completed in 1979. The construction phases started in 1981 and the first settlement comprising of 516 housing units was settled in 1983, whereas half of the total area was planned to allocate to houses. The other half was intended for physical, social, and other special needs of a settlement of 250,000 people. The development of Batikent was prepared following the important guidelines in order to achieve a well-ordered environment. In respect to this plan, Batikent comprises of 5 different scale units identified in various characteristics. So the impact of these designs were to contribute and promote the urban cooperative movement as well as the cooperative movement as a whole for this kind of urban settlements. Another impact it definitely had was the development of housing and urban development policies within the region and its implications on the local and national policies, that's mass housing laws, its achievement in planning and projection implementation, its contribution to the creativity of sociological, desirable and sustainable environment, and also enabling the people to help themselves through cooperative and other civil initiatives. It also provided affordable shelters to those in demand and also developed an integration system within the community. It also helped to design a healthy environment and also the promotion of civic participation and responsibilities through a self-help organization in its cooperative system. So these criteria were Batikent being designed as a whole, then being looked into as a district, then as a quarter, then as neighborhoods, then comparative blocks. So the Batikent as a whole, like I said, was 250,000 people with educational facilities, meaning the public and private sector, hospitals, cultural recreation spaces, public and commercial services. Then the districts were divided into 5 for 50,000 people each. This also housed some educational sectors and some healthcare facilities, mosques, theaters, municipal services. Then the quarters served for 10,000 people capacity. Then also the neighborhoods for 5,000 people capacity, also with little polyclinics and also some minor cultural recreational activities. Then the cooperative blocks, which are the housing units, were for an average of 1,000 people each. These ones mainly had the small commercial services like newspaper stalls, groceries, and green grocery shops. Other characteristics that were also discussed and were applied were the high efficiency of pedestrian accessibility, walkability within the town, the security of pedestrians, the integration of pedestrian and public transportation, the pedestrian accessibility of transportation system, the road hierarchy, the residential working place relationships and alternative routes, then also the neighborhood units for community integration and the coexistence of spatial distribution of activities, meaning the activities were not just clustered within one neighborhood. This would have created so many issues in the future when in terms of overpopulation and others. So it was dispersed so as to spread out traffic and all other population issues related to human population congestion. The graph you can see on the bottom right of the screen is a quick conceptual design of how they planned to divide these blocks into different parts while they were still in the criteria and designing phases of the project. You can notice the open accessibility within these blocks and the ease of transportation from one unit block to the other without any congestion or any obstacles along the way. Also in the designing phase, to optimize cooling and heating of the buildings, some steps were taken in the designing of the neighborhoods. For instance, some buildings were not placed right next to each other so as not to block each other with shade and cause too much cooling during the winter. The building height was increased from the south to north for not to be shades. Also help increase the value of SHF within this design. So they also paid attention to the SHF in order to control how the heating and cooling system works efficiently without heavy reliance on artificial source of heating and cooling. The high-rise apartment blocks were also allocated along the main center. The medium concentration are encircled in the high-rise areas, and lastly the low units were placed along the peripheral of Batikent, meaning they dispersed the population so as not to cause congestion within just one zone of Batikent. Then on the right side of the screen, what you can see is a 3D axonometric model of the matrix of how this design was carried out. This shows the communities within the project along with the accessibility and the greenery that's existing all within the site. It shows open green areas, different commercial and administrative services, and also the diagram shows how the layout has been designed in a compact way, but yet in a very functional and open manner, where it keeps the spaces close to each other and also gives the spaces needed for air circulation and mobility of both pedestrians and the vehicle users. You can also notice a lot of open green spaces. This is also to help mitigate all these characteristics that I have discussed within the site. One of the two low-density housing units I'm going to discuss about is Govengir. It was designed by our professor, Sami El-Yulis. Its density is meant for 350 people per hectare. It's a duplex residence and it has the net area of 120 to 150 meters square. The other one I want to discuss is Ozgur, which was designed also by our Professor Sami El-Yulis. It's a triplex unit with a net area of also 120 meters square. It was renovated 15 years ago and now includes a greenhouse and also some other sustainable and passive design systems like the vernacular architectural approach, solar passive energy design, and also greenhouse gardens, which help regulate the thermal conditions and also provide energy for the users. Density building, which is Fukokshira, was designed by Professor Sami Elridis. It's meant for 225 people per hectare, which is 85 to 100 meters square in net area. It is a 5-story block and also designed with open green spaces, usually open green spaces at the middle of the parcels. Then finally, the last one I want to discuss is the high density housing areas, which was designed for 600 people per hectare. It is generally located around the Batikent center. It covers an area of 102 hectares. These residential environments were mostly 10-story buildings, apartments, usually containing 85 to 100 meters square of residences. It was designed as apartment blocks. So after this case study, I took a site also within the Batikent neighborhood, which I designed my own type of housing. So my main idea for this design was to still maintain the main issues that Batikent tried to handle while trying to tackle some of the issues that Batikent was not ideally designed for. Basically, maybe it was not foreseen during this design process, or unfortunately due to the changing climatic conditions, these issues that have been made worse. So meaning Batikent cannot handle it on its own. So my proposal was to design something that can serve not just the community, but also to help tackle for the possible dangers that are about to face this settlement and its users. My idea is to not just use design to tackle just the main functional activities, but also to use and tackle the urban ecological problems that are facing the location right now. So the size of the site I picked was 14 hectares. The proposal was to design an urban neighborhood with a socio-cultural, socio-economic and urban settlement function. The population intended was for 10,000, minimum of 10,000 people. So some of the design principles I implemented were the improvement of water management system. That's by the use of green infrastructure approaches like biowheels, the bio-retention ponds, rain gardens, and rainwater harvesting, rainwater recycling, that's the grey water and brown water recycling system, and the drip irrigation of more sustainably managed water. I also used low impact materials by reusing and recycling existing materials like the use of wooden mulch and also recycled plastic pallets in the mixture of some of my concrete and asphalt, and some indoor planting units, natural lighting, improvement of indoor air quality, which when utilized properly, the improvement of air quality and the use of plants can increase the air quality, meaning reducing the carbon footprint by up to 80% and increase the health of the users. This can prevent health complications like headaches, asthma, and respiratory problems. Design also wanted to implement some human productive activities. It has been proven that productivity rate increases by 20% in an environment that has a very good air quality. I also wanted to reduce the amount of energy dependency, or let me say the public energy dependency, by the use of solar panels and other design techniques. This will help reduce dependency of artificial air circulation units and also increase the health and also the air quality by further 15%. So the challenges that I was facing in this site were not just locally but also globally. For global issues were global warming, of course, the depletion of natural resources, waste, water shortages within the site, the aging population, the rising tides and natural disasters, and also the local problems were earthquakes because of the location of Turkey in general, the shifting population psychology when it comes to green spaces, and also the implementation of sustainable living, and also the misuse of landscape design. So to tackle this, I was going to implement energy saving and renewable energy usage, longer lifespan design, the waste prevention materials, water saving and recycling, accessibility and universal designs, the adaptive measures to tackle also natural disasters, higher resistance buildings that can resist the more prominent earthquakes happening now, and also for the future, for the shifting population psychology for design, because we might design buildings for now, but the population might have a shifting psychology in terms of what they prefer. So I am going to design something appealing and adaptive to, and also the aesthetics of the user. Innovative and creative ideas for designs also will be used for the misuse of landscape. So what you are looking at right now is a functional layout of my design. I designed 10-story blocks, 5-story blocks, public parks, semi-detached units, and also triplex housing units, just like in the original designs. So for my 10-story blocks, I designed them with duplexes within them. Each block contains 76 units of apartments, and there are 23 blocks in total within the site, with an average greenery of 52% within them. They are located on the southern and southwestern parts of my design. The purpose of this is not just to help block the noise from the Ankara-Istanbul road, which is located directly behind them, but also to help create a barrier, not just with their physical sizes, but also with the greenery within them, for the industrial, for the air quality coming from the industrial blocks. So this creates almost like a barrier for both for the air quality and also for noise pollution coming into my site. Then after them is the 5-story apartments. The 5-story apartments were designed to be more comfortable, with 2 apartments for each floor, making it 10 apartments for each block. And each apartment was a 3-bedroom apartment. There are 47 units of this. It also consisted with a lot of green spaces around it, with the average greenery of these blocks standing at 62%. Then after that, in blue, you can see the triplex units. The triplex units are 3-bedroom units also, and there are 102 in total. This also have the average greenery of 56% within each triplex unit. Then also what I implemented in this triplex units were some green roofing design, and also the option of the users to be able to create a more adaptive design and functions to their individual units. So meaning I give them room for things like greenhouses and also private landscapes where they can use either for farming or for decoration, but either way still providing my main goal, which is to help reduce the carbon footprint of each user from the units they are living within. Then the last one is my semi-detached units. They are also 3-bedroom units, and there are 114 in total. The average greenery within these units is also at 54%. These units also were designed in a way that they help this my new design almost blend in with the old designs within the site. If you notice, the design of this semi-detached units are almost of let me say the modern contemporary way, while the other new ones are designed in a more futuristic and minimalist way. So now back to my site. There are altogether 286 units of housing, meaning there are spaces for 14,000 occupants within them. There's also a lot of green greenery within my site. And the reason why I chose this site layout was because on the eastern side of my site is the Ankara forest, which is also a very good source of greenery. Even though yes, it's going to cause some issues in terms of the heating of my project, or let me say my design, during the winter periods. I have implemented a lot of greenery just along the border with my site, which will serve as a green barrier also of tall trees that will help block this wind. I also implemented a lot of spaces for mobility, both for vehicles and pedestrians along the axis of my site. And if you notice, it helps blend my site totally with the surrounding Batikent neighborhood, and also keeping the original ideology of the design of this Batikent neighborhood, while still giving respect to this design, and also trying to implement my own design principles on this design. So on the right side, you will see just a brief site plan of my functional maps that I used. So I took one of the blocks I designed and made a brief look so that we can have a brief look at it. From the left, I'm going to start with the materials. They also included recycled waste like the wood mulch for the plants, and plastic pallets to mix with asphalt and the pedestrian walking areas. This is to aid in the reduction of cost and also greatly reduce the time of construction, meaning this gives space for the implementation of ideas like the modular design system, and also provides so many other uses. For instance, if you look at the cross section of the road that I designed on the bottom left, this design system gives also storage for water beneath it, as you can see, with the asphalt right above and also the pedestrian right above. Between the asphalt and the pedestrian, I created a green barrier. This green barrier is to serve not just to help cool down the concrete system during the hot summer months. It also will help provide the shaders needed, yes, to cool down the temperature, average temperature of this site, and also as a natural sound barrier for the vehicles moving along it, and also create some sort of a speed barrier. This block serves almost as a unit on its own, because the reason why I went with this design is because each complex is mainly focused in the production of energy from waste, like I said, and from the sewage and the organic trash it produces on its own. So meaning the storage of water and everything that happens within this site benefits the greenery that is just between the buildings, which the users can benefit. And also this is actually one of my five floor apartments, which I'll go into details on it. On the landscape, there will be plain areas, water storage units, both, like I said, below the pedestrian and asphalt roads, and also on above surfaces like water fountains. The implementation of the wooden mulch, like as you can see in my road section, and the use of bio waste to help as the provision of natural manure for my plants. So on this page, what you're looking at is two different layouts of my semi-detached and my 5-block apartments. So on the left is my semi-detached. You can see the greenery surrounding it. On the basement, all my units, both the semi-detached 5-floor apartments, the 10-floor apartments, and the triplexes, will all have CHP water recycling system, and also energy-saving units below them. Meanwhile, on the right, the 5-floor apartments will have green roofs, solar panels, and also basements are converted into CHP water filtration, and also where they install the solar panel power being generated in inverters. The Semi-detached house also has its own basement where the water filtration and the CHP system, and also the batteries to store the passive energy being produced, will be kept. You can also see the semi-detached has a different roofing system, like I said, from the other design, which is the five-story apartment. It doesn't just serve the purpose of being a proper insulator for this kind of design, but also the gutter system also provides a very good storage. Or let me say, a very good way to help retrieve water from precipitation when it occurs in this project. Another system I included in this semi-detached unit is the involvement of skylight. So this skylight unit will be, yes, it will be definitely properly insulated, but also consists of translucent layers which will prevent heating during the summer period, and also this installation provides good and adequate insulation for keeping the building warm, as you can see in the section. Then also, of course, giving a very good natural lighting to the interior of this design. The image you see right now on your screen shows the backyard, or let's say the green space of the semi-detached unit. As you can see, there's a lot of greenery for opportunities to plant, either landscape or as food. You can also see the louvers that provide shading for the outdoor activities like sitting during the summer period, while also help channel water during the precipitation months. And above the roof is the solar panel system. So altogether, they make this design, yes, even though it looks a bit contemporary and fit into the Batikent, but also applying the application of the simple design techniques and elements helps keep this building also be able to withstand the test of the nearer future and be able to be independent in terms of the energy consumption and generation by the users within it. The video you are seeing right now is just showing the layout of the semi-detached units. From above, you can see the skyline with the solar panels on them and the greenery, how they help, even though, yes, it's an open design system for the greenery, this helps in absorbing the heat and also insulate the building during the winter and summer periods. And you can see the asphalt, which, like I said, will help store water for the public, especially during the summer periods where they need to use them to help in watering the greenery and other emergency purposes because of the shortage of water that might be facing this site in the future due to the climate changes happening within this site. So this public storage units, like I said, below the asphalt can actually store water of up to 500 liters per cubic meter. So when implemented properly and around the site, this can store not just water for just the purpose of my design, but also for other activities like the public greenery within the Batikent itself. So meaning it helps reduce the amount of water being consumed from the public sources while using the naturally available water system. So I hope you liked my presentation, and I hope to once again show my gratitude to my classmates and also my professor, Professor Semi Ariildis, for the time and effort he has put in giving us these guides and helping us understand this system of green and sustainable design, or not just at on a small scale, but on a larger scale, which we can all apply in our designs for the future. So thank you and have a good day. Thank you for watching.